Okay, so we're going to look at these. So these are rational expressions, because you guys know rationals, like the numbers, just means you can write it as a ratio, as a fraction. So these are rational expressions, meaning they're not just ratios of numbers, they're allowed to have this algebraic expression type of thing inside of it, okay? We're going to simplify these, and we're also going to say what values they would be undefined for. When is a fraction undefined? Morgan? Good. When the denominator is 0, because dividing by 0 doesn't give us any results. Like when you try to do 6 divided by 0, you can't come up with any answer that makes that true. So I'm telling you that we're going to look at this fraction. We're going to say it's undefined when x is this, 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 or this, and it simplifies down to be this. So before we start, I want to make something really clear, that we cancel factors and not terms. So what I mean by that, I'm going to write off to the side. Let's see. All right, 6 over 12. 6 over 12 reduces to what? 1 over 2. So the reason 6 over 12 reduces to 1 over 2 is because if we factored 6, if we wrote it in its most factored form, we would write it as 2 times 3, and 12 would be 2 times 2 times 3, right? And then if we canceled out the common factors, this 2 would cancel, this 3 would cancel, and we would be left with 1/2. This is literally what we're going to be doing. Okay, we're going to factor things, and then we can cancel out common factors. They're just not always going to be numbers. The factor might say like x minus 1 in it or something like that. What we have to be aware of is that we're always canceling factors and we're not canceling terms. Does anybody think they know the difference between a factor and a term? Morgan? Okay, good. So let's say that we had 6 plus 1 over 12. Okay. Are we allowed, and we've actually talked about this a bunch because some of you keep doing this with quadratic formula, right? Are we allowed to just say, oh, 6 and 12 have this common factor of 6, so 6 reduces to 1 and 12 reduces to 2. Is that okay? No. Okay? The reason that's not okay is because we can cancel common factors, but we don't cancel terms. In this problem, everything that was in parentheses was a factor, because when we looked at those parentheses, the only thing that set of parentheses was doing with the other stuff in the problem was multiplication. So factors have multiplication between them. In this problem, 6 is not a factor. Okay? 6 is not a factor because 6 is actually being added or subtracted with something else. That makes 6 a term. Is that okay with everybody? Which means even in this problem, if I rewrote it, I still cannot cancel out the 2's and the 3's. Down here, the 2's and the 3's are factors. Is that okay with everybody? They are just plain factors because what's the only thing this 3 does to anything else here? It's only involved in operations of multiplication. Up here, this 3 is involved with multiplication with the 2. However, it also is involved in addition eventually with something else. Do you guys see the difference between being able to call something a factor and not being able to call it a factor? So like here, all the 2's and 3's were factors. Here, these ones are factors. They're ready to cancel out because they are only involved in multiplication. But up here, they're not, even though right here, they're like, oh yeah, they're multiplying. Yep, but later on, they are going to add with something. Okay, so what this means. I'm going to give you guys an algebra expression now. All right. This is the same thing, but now instead of inside of my factors being a single digit, inside of my factors is an algebraic expression, okay? Right now, each of these is a factor. This group is a factor because as a group, the only operation that set of parentheses is involved in, not what's inside of it, but if I count it as a group, like x plus 1, like not like they're separate, just like one thing, x plus 1, right? If I count it like that, that thing, when I look at the others, is involved in multiplication here, and there's multiplication later on, but it's not being added or subtracted with anything else, okay? So that set of parentheses is a factor. So is this one, and so is this one. This one could be thought of as two factors, a 3 and also an x, because not only can those things be broken up by multiplication, they're still only multiplying the other parts of the problem up there, okay? Inside of this factor, there are two terms. So I'm not going to look at the x and the 1 as separate entities when I'm thinking about factors. Like I said it really fast to try and be like slightly funny. X plus 1 is like one thing. Is that okay with everybody? All right, so the denominator's factored as well. 3 is a factor, x minus 5 is a factor, x plus 1 is a factor, and x plus 2 is a factor, because those groups only experience multiplication with the other things in that portion of the fraction. I am allowed to cancel any common factors. So I can cancel x minus 5 and x minus 5. I'm not canceling the x and canceling the 5. The x minus 5 is one package, right, as a factor. I can cancel the entire x plus 1 and x plus 1. I can't cancel x plus 2. I can cancel the factor of 3. Is everybody okay that that's because it wasn't 3 plus x in there? It was 3 times x, which is slightly different, okay? Which then means when I'm left with this, can I cancel the x's? No. Here is x a factor? Yes, okay? Here is x a factor? No. It is a term that is part of a factor called x plus 2. Okay? Morgan? Uh-huh. Yeah. So Morgan's question was, what if this was x plus 1 squared? Then I would have probably maybe even taken off of it and just wrote another x plus 1 here. So one of them will get canceled out, but one of them would be left over. Okay? Oops. Is this okay with everybody when we're saying the word factor? This might seem really silly to you, but I think this is the reason, my personal opinion, is that what I see people do is they get here and then they're like crossing out x's all the time. And I'm like, what? Why are you doing that? And they're like, oh, x and x, it makes 1, just like you guys have been doing a lot with your quadratic formula simplification. But this one is a factor. This one's not a factor. It's part of a factor with x plus 2. Does that help clarify a little bit? I know it seems like an intense vocabulary lesson, but it's just because people tend to cancel out terms when they shouldn't be. We should only be canceling factors, okay? So when we look at the problems that we're going to work on, the first one, part A here, has been mostly factored for us, okay? And so you want to see, is there anything else that hasn't been factored all the way? Because we really want to break down as many factors as we can so we know what we're allowed to cancel. So is there anything in part A that hasn't been factored all the way? See Morgan for sure. Brandon? Yeah, the x squared minus 4 could be factored a little further. So it could be factored as x minus 2 and x plus 2. So you guys are going to be using a lot of factoring here. So if you still struggle with factoring, you want to make sure that you come in to get help with that, because we're not going to be able to cancel stuff until we factor it. So does everybody see the factors? Okay. In the numerator, I kind of view it as like 3 factors. A factor of 2, a factor of x, and a factor of x plus 1. Like I'm thinking about that as one package because I'm trying to look at them as factors, right? In the denominator, I see 3 factors, x plus 1, x minus 2, x plus 2. Okay? So what can I cancel? What are common factors in both the numerator and denominator? Emily? Good. Okay, so I cancel out my x plus 1. I am left then with 2x over x minus 2 times x plus 2. Is there anything remaining that I can cancel out? No. Now it's super tempting, right? There's 2's and there's x's, but when I look at this numerator, a 2 could be a factor and x can be a factor, okay? Those are things that I could cancel out if they have another factor just like them in the denominator. But in the denominator, I can't separate this package. It's not an x and a 2. As a factor, it is one thing, x minus 2. And then there's one more right here, and it is one thing, an x plus 2. Okay, and we don't have exactly those factors anywhere, so there's nothing further to cancel out, and that's as simplified as this expression can get. Okay. For the restrictions are just listing all the values that x could not be, like someone would not be allowed to use if they were trying to plug things in for x here. And that would be getting that 0 in the denominator because we can't actually finish calculating that. And we have to, even though the x plus 1 cancels out, we have to look at the original one. Because if someone tried to plug in, let's see, look at our answer. Since the denominator has x plus 2 in it and x minus 2 in it, what x value should somebody definitely not be plugging in here? They're not going to get an answer. What would they plug in here that would result in having 0 in the denominator and not having an answer? 2, right? And then here, negative 2. So definitely our restrictions would be that x can't equal 2 or negative 2. But there's actually one more restriction, because even though our goal was to make this problem simpler, we always have to write our answer with a reflection on the original problem that someone gave us. And so even though we canceled out the x plus 1, notice in the original problem, it also was a factor in the denominator. So if somebody tried to plug negative 1 into this original problem, they would get a 0 over a 0. What is 0 divided by 0? Could be like anything, is it nothing, right? It's like a weird question. Again, it's something that's undefined mathematically. So we really have to look at that original problem. Negative 1 would also be a restriction. It might seem silly to you now that we're listing the restrictions, because it kind of is. We're just basically telling someone, hey, if you ever did want to use this, don't plug in these numbers, which seems like there's no purpose. However, later on when we're solving something, like if this was in an equation, these restrictions we would know are numbers that cannot be our final answer. So if we get them, there's something wrong. Also, when we go to graph later, we're going to graph stuff like this. Okay, I know, a little bit crazy. Okay, when we go to graph it, we'll want to know what those restrictions are because they're going to make certain boundaries on our graph. Like, hey, you can't plug in this x, it doesn't work. So we're just kind of getting used to identifying those restrictions. Okay. All right, so let's look at part B. So the first thing I'm going to do is factor what's there. Because right now, the way I'm viewing it, I can't cancel out anything. I can't start canceling out those A's or 3's and 6's or anything like that because the way everything is written right now is not in a factored form. Because anything that you might say, well, this is a factor, it's multiplying this. Yep, and then that whole thing is subtracting with something else. If you say that it's going to add or subtract with something else, then it alone cannot be canceled out because it is not a factor, okay? So we want to instead write it in this format where we have like all these things multiplying each other. That's how we know it's factored form, because between these things is multiplication, and then we know that every set of parentheses represents a different factor because it's only participating in multiplication. So remember that our factoring rules, we'd take out the GCF first. So like in the numerator would be a cubed, and it would leave us with 3 minus a. And then in the denominator, it would be 2a squared, and that would leave us with a minus 3. So this is looking a lot better. Like I can see my 2 as a factor. I can see my a squared as like one factor, or I could think of it as a times a, however you guys want to do that. Same with a cubed and these groups. And these groups look really, really similar. But we have to look a little bit deeper because subtraction is kind of tricky, right? Like 5 minus 1 is not the same thing as 1 minus 5. They both get 4's in them, but one's positive and one's negative, and those are different values. So I'm going to take the one that's written like the non-traditional way. Like, you know, normally we write the variable first. And I'm going to rewrite it with the variable first. So like, what is 3 minus a? It's an A and a 3, and when you rewrite it, you can write the A first and the 3 second. You just have to keep their signs with them. So when this says 3 minus A, the A is negative or positive? Negative, and the 3 is positive. So that's the same thing as saying negative A plus 3. Is negative A plus 3 the same as A minus 3? No. Can I factor anything out of a negative A plus 3 to look at it just in a little bit of a nicer way? Yeah. Okay. Do you often use a negative and your lead coefficient when you're trying to write it in like the simplest form for you? Like even when I factor, I'm not saying it's right or wrong. I just like if the first thing's negative, I take a negative out right away so that I can deal with what's left, just because traditionally we write things with that positive x first or whatever. So if I take a negative 1 out of this, then that would leave an A and minus 3, and that will be helpful. So I'm going to rewrite the numerator. So it's like a negative 1 that I took out. There was an A cubed that's already up there and an A minus 3. Is this okay with everybody? I just wrote it in their traditional spots, but it might throw you for a loop. So the A cubed was already a factor there. I took the negative, this quantity became this. So I wrote the negative 1 here, and then here's my A minus 3. Okay? And I didn't have to do anything fancy to the denominator. All right, so what can be canceled out here? This is the most factored form, okay? But like, is 3 a factor? No, okay? It's a term within a factor called A minus 3, right? So A minus 3 is an entire group. I can't cancel out just the A or just the 3, but I could cancel out the entire A minus 3 if it has a common factor. And in this case, it does. So I can cancel those out. And then I have a negative A cubed in the numerator and 2A squared. How do those simplify? So like in the denominator, how many factors of A do we have? When this says A squared, how many factors of A is that? 2. A times another A. And this says A cubed, and that's how many factors of A? 3. So the factors of A will cancel each other out, right? Which has more, the numerator or the denominator? The numerator. How many more does it have? 1. So these 2 factors will cancel out all of these except for 1. Okay. And so we're going to end up with a negative A in the numerator and a 2 in the denominator. And then for our restrictions, we want to look at the original problem and say the values that would be bad to plug in for A. So I want to look at the original, but I want to look at the original in its factored form because factors help me see all the different things that could multiply to make zeros in different places. So I like looking at it right here. So what would make A minus 3 equal to 0? 3. What would make A squared equal to 0? 0. 2 will never equal 0, it's 2. So if A is 0, we'd get a 0 in the denominator, or if A is 3, and so those are the 2 restrictions that I'm going to include here. Okay. All right, so look at part C. What's kind of nice about part C compared to the problems that we just did? I feel like this is a nicer problem than what we just did. Stefan? Yeah, they're all factors already. Is everybody okay with that? That there's no addition or subtraction at all in the numerator, so I don't have to try and factor it or think real hard about if that's a factor on its own or part of a larger factor. They are all factors. So the numerator is made up of a factor of 2 and 2 factors of A. The denominator is made up of a factor of B, a factor of 5, 2 factors of B, and a factor of C. Okay? Are there any common factors in the numerator and the denominator? No. So like this is as simplified as it gets. It doesn't simplify. Okay? There are still some restrictions. What would be the restrictions for this? What can't happen? What could somebody not plug in for any specific variable that's not going to work? Okay. 0 for which variables? B or C, right? So we have to say you can't let B equal 0 and you can't let C equal 0. So we are technically doing multiplication and division as well today. The reason they're all grouped together is if you guys remember fraction multiplication, what do you do with fraction multiplication when you're trying to figure it out? Like if you were explaining to someone the procedure just really briefly, if you have two fractions and you're trying to multiply them, what do you do? That's when we're dividing. So when we divide, we multiply by the reciprocal. And then as soon as we set up a problem where we have like fraction times another fraction, what is the procedure to get the answer? You just multiply straight across, right? So like all the factors. So this becomes, all of these become numerator factors and all of these become denominator factors, right? So the reason we're doing multiplication and division with simplifying is because they're really the same thing. Division gets turned into a multiplication problem, right? Like in part D, I can take what's here and I can turn it into a multiplication problem by doing what Emily said and multiplying by the reciprocal. And even though we have this multiplication symbol between it and we're seeing this as like two separate fractions, what's really happening is that all of these are factors in the numerator, right? And this one doesn't have anything for me to factor down further. And all of these are factors in the denominator, okay? Any common factor from the numerator can cancel with any common factor from the denominator. So who sees things here that could get canceled out or can simplify and reduce a little bit? Brandon? Okay, so here. All right, so let's just start with the 5. What does 5 have a common factor with? 15, right? So 5 and 15 can reduce their common factor, which is 5. And what would that leave me with? Yeah, so 15 is really like 3 times 5, and it's the 5 that's getting canceled out, so I'm still left with a 3 here. Okay. And numerically, 8 and 2 have common factors, right? Like I could think of 8 as 2 times 4, and the 2's could get canceled out, but I'd be left with a 4. Okay. So numerically, I have a 4 and a 3. Can we cancel out some A's and B's, and can we cancel out some X's and Y's? So there are factors of A's in the numerator and denominator. How many factors of A are in the numerator? So you're looking across here. 1 factor of A. How many in the denominator? 2. This 1 factor of A will cancel one of those factors of A, leaving a single A in the denominator rather than 2 factors of A. Okay. What about B? Can somebody tell me, once they're canceled out, what we would have as the result for factors of B in this problem? I see Brandon here. Yeah, correct. Good. B cubed in the numerator. So this 1 factor of B would cancel out 1 factor of B here, leaving 3 of them. So we'd have B cubed. Okay. What about X? Somebody new. Tell us about X. Brandon, go ahead. Good. Singular X in the numerator. That 1X cancels out one of these, leaving a power of 1, which is just X in the numerator. Okay, and then finally Y has the same kind of relationship. This Y cancels out one of these, leaving a single Y in the denominator. Okay. Our restrictions here are a little bit tricky because there's like a ton of them because of how many things you use in the denominator. You can't have this be 0 originally, and you can't have this be 0 originally, which means A can't equal 0 and B can't equal 0. But then because you use the reciprocal and you flip over that dividing fraction, you also can't have a 0 down here. Because if there was a 0 up here and someone flips it over to do the division, they now wouldn't know what they were dividing by. So also, X can't be 0 and Y can't be 0. So the division problems are probably the most annoying ones to write restrictions for, because you have to look at the first problem and make sure that none of the fractions by themselves have denominators equal to 0, which is where we're getting these things. But then because you flip one of them over, you have to make sure that it actually didn't have a 0 in the numerator also, because now the numerator becomes the denominator and you can't have that happen. Okay? All right. Is this okay with everybody, this basic idea of what we're doing? All right, so the try these problems are there. If you guys do them, come in, let me know. I can post the solutions on Canvas. But we're going to focus on these two problems. All right. All right, so part A. Can I cancel out the matching x squareds? No, because the x squareds are not factors, okay? Why are they not factors? Good, they're terms because though the x squared is there and it's like x times x, what's the next thing that's happening to that x? It's being added or subtracted with something else. If anytime what you're looking at is being added or subtracted with something else, it is not a factor. Right now, if we viewed this problem the way it's written up here, the numerator has one factor right now. This whole thing would be a factor. Because there's nothing else inside of it I can say is purely only multiplying and everything. Everything in there eventually is adding or subtracting with something else after it multiplies. And right now the denominator is only one factor as well. Is that okay with everybody? People don't write parentheses around it. I just think it helps your brain understand like the group kind of thing, okay? Can I possibly factor these further? Okay, can I break them up? Possibly, right? So if we factor, just using quadratic factoring, our denominator would factor to x plus 3 times x plus 1. Okay? So I just changed it from having one factor to having two factors. Is that okay with everybody? And x is not a factor, 3 is not a factor, x plus 3 is a single factor. Okay? In the numerator, if I factor x squared plus 2x minus 8, I get x plus 4 times x minus 2. All right, so now when I view the numerator, I see it as two factors, and I see the denominator as two factors. Are there any similarities? Are there any factors in the numerator that also exist in the denominator? Okay, so there's only two. So the first factor in the numerator is x plus 4. Do you have another x plus 4 in the denominator? No. The other factor is x minus 2. Do we have another x minus 2 in the denominator? No. So even though we could factor it, nothing canceled. And in this case, there's no way for us to factor it any further because these factors are already of degree 1. You can't pull any more x's out of them. So this is our answer. And you guys could either keep it in the original form or you can keep it in your factored form. It doesn't matter. It just didn't simplify. Okay. So whether you have a division problem, a multiplication problem, whatever, that's how you'll treat it. Factor first, then look for things to cancel. Don't start canceling out terms. Okay. All right, and then part B is to get us used to some notation. It looks ridiculous, right? But it looks a lot less ridiculous if we write it out horizontally. What do the fraction bars, I just totally told you the answer. What do the fraction bars mean in math? Division, right? So this is really a fraction divided by a fraction. My advice to you, write it out horizontally before you start doing anything else. So if I wrote it like this, it probably wouldn't have even looked that strange to you based on what we've been doing so far today. This is essentially what we're doing. It means the same thing, okay? It just looks a lot crazier all stacked together in a single fraction, right? So this is what we're doing. And so now remember that division with fractions, we can change it to multiplication and use the reciprocal. And that having multiplication is really like having one fraction because the numerators will all just combine together to still be in the numerator, and same with the denominators. But we want to cancel out factors. And right now, if I'm looking at this, if I wanted to think about factors, the way I see it is I have a factor here, a factor here, a factor here. And you could probably think 4 can be separated from A. That's where I see the factors right now, but I can do some factoring and rewrite things in a more factored form. So for example, 5a squared minus 20. If I take out the greatest common factor of 5, That leaves me a squared minus 4, and a squared minus 4 is one of our special factoring patterns. So that actually becomes 5 times a minus 2 times a plus 2. So that's the way I'm going to write it. What about the denominator down here, the 2a plus 2? What can we do to factor that? What, Noah? Yeah, we can factor out the 2. That leaves it a plus 1. Okay. Here you can leave it as 4a. If you want to break 4 down into 2 and 2, you can do that. I'm not as concerned about the numbers because you guys are pretty good with the numbers. And then 10a minus 20. The 10 can be factored out. And that will leave us with a minus 2. Now, remember, all of these from both fractions are factors in the numerator, and all of these are factors in the denominator. So what are the common factors that we can cancel out? So can we cancel out a plus 1? No, there's not another one, right? Can we cancel out a minus 2? Yes. Factor, factor. Okay. Then numerically, okay, 5 goes into 10 2 times, okay? And both of these 2's can cancel out both the factors of 2 that would be in 4, okay? Just like you would reduce a fraction. So in the numerator, I have an a and an a plus 2. And in the denominator, I have an a plus 1. Did I miss anything? Is there anything that can still be factored out or canceled out? Can you cancel any of the a's up here? No. This one could be canceled if there was another one just like it. But remember, this a plus 1 is a factor. It's all together. It's not technically needs parenthesis around it. It doesn't, but I think that helps you guys see better. So this is the most simplified form of what I have there. Okay. Any questions?